My name is Carla Lara. I work in the development and technical support groups here at ChemStations, and I'm your presenter for this webcast. Our discussion of the charting tools in ChemCAD will include how to find and select a chart, the concept of an active chart, the types of charts available in this version, the improvements made from previous versions, and a quick demonstration of these features in ChemCAD using an example simulation. In ChemCAD 7 and earlier versions, charts were all listed in the plot menu. Selecting some charts like column profiles required multiple clicks, and we repeated this process even when generating the same chart again. The plot menu has been replaced now by a single command, and that is the charts command in the results group of the Home tab. This command works as both a drop-down and a one-click button. Clicking the Charts drop-down opens the new Charts gallery, where the charts are organized by category, and each chart has a representative icon as well as a text description for us to quickly find and generate the chart we want. All we need to do is open up the gallery and select the chart. Once a chart has been generated, the icon of the charts command will update to match the icon of the most recent chart. We can save a lot of clicks by simply clicking the charts button to generate the same chart again and again. Or we can always use the drop-down to select a different chart. Every time we generate a chart, a new tab will appear at the bottom of the ChemCAD interface. If we can see the chart, then that means the tab is active. And we can easily switch between charts by clicking any other tab. Once a chart is active, we will see an additional tab in the ribbon labeled Chart. This contextual tab contains all the features that apply to the chart that is active. So different chart types will have different features, and the look of this chart tab will update accordingly. The new chart engine can generate 3 types of charts. XY charts are the most common and have the most features. One or more data series are plotted in 2 dimensions. From thermodynamic diagrams to unit-up charts to sensitivity, XY charts are used everywhere in ChemCAD. Ternary charts are only used to display binodal and residue curves. Composition data is plotted in a triangle, and they are helpful for designing separation processes for highly non-ideal systems. New to this version, we introduce you to the surface charts, which can only be accessed through the sensitivity analysis tool, where data is plotted in 3 dimensions, and they are very helpful in visualizing complex relationships among variables. And now I'll do a quick run-through of the improvements to the charting tools in ChemCAD. Compared to previous versions, the new chart engine generates smoother and neater graphics. Here we have an XY chart in ChemCAD 7 on the left, and the equivalent chart in the next version of ChemCAD on the right. And likewise, we see a vast improvement when comparing the drawing of a ternary chart. Not only are the charts better rendered, but also easier to read. Once a chart is generated, we can zoom into a section by right-clicking and dragging to create a rectangle, or using the mouse scroll wheel to zoom in. To read the plotted values at any zoom level, simply hover the mouse pointer over the data markers. The features available for any charts is greatly improved when compared to CHEMCAD 7 and earlier versions, with the charting tools were all listed in the chart menu of the active chart. Customizing any chart usually required multiple clicks. In this version of CHEMCAD, the features that apply to the active chart are all in one place. This layout brings visibility to both old and new features, especially the lesser-known ones, such as the ability to save the chart inside the simulation and the ability to export the data to Excel. By the same token, with this layout, it becomes much easier to change the labels and settings of the chart as a whole and of the individual axes. When it comes to settings that apply to the chart as a whole, charts are typically generated with markers connected by straight lines. Using the type dropdown in the chart settings group, we can hide the markers and display the line only, or hide the lines and display the markers only. Likewise, we can use the legend dropdown to move the legend from its position on the right to any other location or even hide it from view. A less common but sometimes useful feature is the fixed axis location option. For charts where the values on either axis change from positive to negative or vice versa, unchecking this option forces the axes to intersect at the origin, which can make the charts easier to read. And finally, to further improve the look of a chart, we can check the spline option to redraw the graph using smooth lines instead of our default straight lines. Additionally, there are plenty of formatting options available for the individual axes. It is possible to change the format and precision of the numerical values on any axis. For instance, in this chart, we are using scientific notation for the y-axis. Similarly, we can change the color of the axis grid line in order to make it easier to read along the chart. Once we've picked the color, we can adjust the tone from dark to light using the grid fade arrows. This feature is particularly useful in helping us read along ternary charts and even surface charts. Also available for XY charts is the ability to change the scale of any axis from linear to logarithmic by toggling the log scale option. And last, but definitely not least, is the introduction of the multiple y-axis feature. When a chart is generated, every data series is plotted on a single y-axis, where it can be hard to identify relationships among variables if their values are very different. With this version of CHEMCAD, however, we can click the Assign Series button to put one or more data series in the secondary and even tertiary y-axis to scale the data properly. For a quick demonstration of these features in CHEMCAD, we will look at the distillation process that separates benzene and toluene. Here, a trade column is equipped with a total condenser and a partial reboiler, and the goal is to optimize the column design to meet the distillate and bottoms purity specifications. When modeling a separation process, it is useful to look at the TXY diagram to validate the thermodynamic selection and determine if distillation is even feasible. And once the column is specified and run, plotting the temperature profile can show if the current feed location is optimum or not, depending on how smooth the profile is. These are the charts that I'll show you how to generate and customize. So now we are ready to jump into CHEMCAD for a live demo of the charting tools. So here I have the CHEMCAD window open, where I have a single distillation column and the total condenser and partial reboiler are being modeled separately to accurately calculate the amount of utilities required to run the column. As mentioned before, this is a benzene toluene mixture that is being separated in a distillation column. And it's just with any separation process, it's a very important aspect of process simulation to validate the thermodynamics model selection. And an easy way to do such sanity check is to look at a TXY diagram. So on the Home tab, in the Results group, we find the Charts command. We click the drop-down to open the gallery and see the wide variety of charts available in CHEMCAD. And right under the thermodynamics section, we find the TPXY chart that once clicked, opens the TPXY options dialog. Here, I'm only interested in plotting the TXY diagram of benzene and toluene at atmospheric pressure. By clicking OK, I now have the chart in view, and I notice a tab along the workspace next to the Simulation tab. I also notice the contextual tab labeled Chart at the very top. The information and the options shown under this tab apply to this particular chart. A TXY diagram is a two-dimensional representation of the vapor-liquid phase envelope of a binary mixture. And here we have the bubble point temperature in blue and the dew point temperature in red. Both temperatures are plotted as a function of the benzene weight fraction in the same y-axis. By clicking the Assign Series dropdown in the y-axis pane, we can decide which curves to show on this axis. Clicking the vapor curve will deselect this curve from this axis, thus leaving the liquid curve on its own. We can then go and add the vapor curve to a different y-axis by opening the dropdown and selecting vapor. If desired, we can override the axis labels and chart title by typing directly on the fields. We can also do things like replacing the legend from its right position to the bottom of the chart, or even changing the grid line color on the x-axis by clicking on the formatting button and then choosing a color that will make these grid lines more visible to us. When finished, we can either save the chart inside the simulation, export the chart to Excel, or if there's nothing else we would like to do with this chart, we can either hit the X button at the very top of the tab or click on the Close All Charts button. Now, for analyzing the performance of the column itself, it is helpful to look at the column profiles chart. First, we select the column unit operation, and once again, we open the charts gallery until we find the column profiles chart under the unit op section. Once we click it, we can review the information that we are about to plot. For this case, it's just the temperature profile, and we hit OK. This chart is showing us the number of stages plotted on the y-axis and the temperature along the column on the x-axis. You would notice that some of the functionality, even for this XY chart, has been disabled because of the flipped axis condition for this chart. From looking at this chart, we can infer that the current feed location is not optimum, since there is a sharp discontinuity at stage number 24, the current stage. Without closing this chart, I can go back to the simulation and open the controller unit operation ID number 1 upstream of the column, which is a unit operation I'm using to adjust the feed stage relative to the actual number of stages. So currently, the feed stage is being positioned 3/4 of the way for a column with 32 number of stages, and therefore the feed location is stage number 24. I can change this value so that the feed is entered at a much higher in the column, closer to the top. Click OK, and click Run All to rerun the simulation. To view the updated chart, instead of going to the gallery, I can use the charts command as a one-click button and directly click on it to regenerate the chart that I just did. So after selecting the column and clicking OK, I will see the exact same column profile chart dialog that we saw before. Hitting OK will present to me the new updated version of the chart with the current state of the simulation. And here we can also see that the optimum location is far from 1/4 of the way of the column. Having this chart open, there's other customization we could do, but at this point, what I'm interested in is actually finding out what the optimum feed location could be, and that is going to lead us into the second half of this webcast. So without anything else to cover for charts, I'm going to close all of them at once and go back to our presentation. So this concludes our discussion of the charting tools in CHEMCAD. And for the second half of this webcast, our discussion of the sensitivity analysis tool will include how to access the tool, the concept of an active analysis, the chart options available in this version to visualize the results, the improvements made from previous versions, and a quick demonstration of these features using an example CHEMCAD simulation. For those unfamiliar with sensitivity analysis, by definition, it is a tool used to automatically vary stream and unit op parameters over a defined range of values and record the results of each run. Sensitivity analysis is a very powerful tool. It can help us identify operating limits, find the variables that have greater impact in our process, and determine if a minimum or maximum exists when plotting a key result. In CHEMCAD 7 and earlier versions, sensitivity analyses and their options were all listed in the Run menu. Running the analyses or plotting results require multiple clicks, and we repeated this process when using any of these commands. This complex structure has been replaced by the sensitivity group in the Analysis tab, where all the commands are now one click away. Every time we create a new sensitivity analysis, this analysis is added to the selection dropdown. And we can easily switch between sensitivity analyses by clicking the drop-down arrow and selecting a different analysis. Once selected, all the commands in the group apply to the active analysis. In sensitivity, we can visualize the results using 3 types of charts. A line chart is just an XY chart, where one or more recorded variables are plotted in 2 dimensions to show the effect of changing one independent variable. A surface chart is a new type of chart. One of the recorded variables is plotted in 3 dimensions to show the effect of changing 2 independent variables simultaneously. Different colors are used to indicate the relative highs and lows of the dependent variable. When the 2D projection option is checked in surface, the recorded variable is instead plotted in 2 dimensions to show the effect of changing the first independent variable for fixed values of the second independent variable. Before the implementation of the surface in this version of CHEMCAD, this chart was the only chart type available for visualizing the results in CHEMCAD 7 and earlier when varying 2 independent variables. So to recap, the webcast covered the new and enhanced features for charts and sensitivity available in the next version of CHEMCAD. In the first half, we showed how to find, generate, and customize charts using the available features in the contextual tab. In the second half, we showed how the changes to the user interface, the chart engine, and the calculation engine have allowed us to unleash the potential of our sensitivity analysis tool, making it easy to run and visualize complex analyses in a reasonable amount of time. We thank you for attending this webcast, and please stay safe and healthy.